play around with Google Docs and come up with at least 3 tips that you want to share with the rest of the class. Just bring them in, write them down. We're going to discuss them out loud. We're going to discuss them out loud, so you don't need to you don't need to type them up, but make sure you know what they are so you can bring them in. Does that make sense?
What kind of tips?
What kind of tips? You look around in the system, you find something neat that you think everybody else should know about, you run into an issue and you solve it. I want you to use the system long enough so that you can discover something interesting about the system, or discover something neat that it does, or a limitation that it does. Just play around with it. Yeah, the STJ Labs docs. Yeah, STJ Labs docs. Yeah, you wrote your paper in it, right?
Oh, yeah.
docs.stjlabs.com. You use the system. This is a more general word, would be observations. You could write 3 observations. Okay, so use it, see what happens, try to break it, see what happens, okay? The question I'm going to ask you is, we're going to do these in order. In general, how familiar are these 5 topics? How familiar are they? Do they semi-familiar? What do you think? Kinda? You've seen some of the words before? Some of the words before? Let's do this. Just by a show of hands, how many people have seen most of 1.1 before? 4 ways to represent a function. You've written equations before. You took Algebra 1 and Algebra 2. Yeah. Domain and range. We talked about domain a little bit yesterday, so it should be pretty familiar. A little bit. Piecewise defined functions. We covered that a little bit yesterday too, right? Now, had you seen piecewise functions before?
Yeah.
The last question on it yesterday? Uh-huh. Now, the last 2 maybe you haven't seen before. Have you ever seen the word symmetry in a math class? Symmetry? Yeah. Mr. Weston's class. And what about increasing and decreasing functions? Do you think you could figure out what that is, or have you heard of that before? You have? Okay, so this is what I'd like you to do. You're going to take 5 minutes, and on your own, so take out a piece of paper, you're going to write at least 2 things that you know about each topic. So you're going to do that right now. Spend 5 minutes, write down at least 2 concrete things you know about each topic. So, with regards to 1.1 here, start calling on people at random. You like that? No? You do? Kind of, maybe? Sort of? Yeah. Olivia, what's one thing you can tell me about 1.1? What's one thing? That's a noun, yeah? Sure. Y equals mx plus b. What is that called? Something form. Slope, what? Intercept form. Sure. So that's something you already knew. That's great. How about, he's not here. Let's go with Steven, who's also not here. Macy, can you give me something else about 1.1? Point slope form. Can someone tell me what point slope form is? What is it? Give you a hint. Y minus. Yep. Yeah. It's there somewhere. You just gotta like dig it out with a crowbar. Yeah. This is what? This is point slope form. In both of these equations, what does m equal in these? And what does x1, y1 represent in the second one? Any point on the line. Let's do a little bit more here. Let's go with Magoon. Do you have anything else you can add? Both ears already up there? Does anybody else have anything to add to the first? Yeah, go ahead. Oh, sure. How many people have used that before?
y1 minus 1.
Ah, there's a question for you. Does it matter which order you do it in?
Yeah, I don't know.
Why doesn't it matter?
Y doesn't
What are you doing to each of the divisions?
square.
Ah,
Square.
what's the relationship between A minus B and B minus A?
They are
They're not the same.
They're reciprocal.
They are not reciprocals. They are opposites of one another, right? They're opposites of one another. 2 minus 5 is negative 3. 5 minus 2 is 3. If you square something that's opposite of one another, square two things, what happens? They become equal, because you know that negative A squared equals A squared. So does it matter what order you do it in? No. I recommend being consistent. Choose one and go with it. And also, which one is x1, y1? Which one is x2, y2? We don't have a rule for labeling, right? So it doesn't matter. In general, you see it written this way. Anything else people want to add to 1.1? Yeah, Justin, go.
I got just the quadratic formula.
Ah, quadratic formula. Which is what?
Minus b
Yep.
plus or minus
Yep.
root b squared minus 4 times a is c and divided by 2a.
Yes. Can anybody remember what this is called right here? Anybody remember? Discriminant. The discriminant. It's kind of important. You want to calculate that first. Yeah? The vertex. The x-coordinate of the vertex. X equals negative b over 2a is the x-coordinate of the vertex. Mm-hmm. Nice. Yeah. Ah, vertex form. You guys remember a lot of stuff. X minus h squared plus. Okay, that's great, yeah. And what is hk? It is the vertex, yeah. That was very good, yeah. Excellent. Nice. Anything people want to add for the first one? Anything else? You guys remember a whole, look at this. Remember a whole lot of stuff. All these are going online. In note form and video form. Anything else people want to add? Okay, we'll move on. Let's go think about 1.2. That's domain and range. Uh-oh. Gets harder. Denise, do you have something about domain or range? No? It's okay. You can go pass. That's fine. Stanislaus. Domain generally refers to x values, and range, generally speaking. Is that always the case? No. Not always the case, but generally speaking. Okay. Hanley, what can you tell me about domain or range?
Can I say it's usually used in graphing?
It's part of graphing. It's important. Yep. Mm-hmm. The domain of a function f of x is the what? Can anybody finish that? The domain of a function f is the Can anybody come up with any observation about domain? It's the set of all what?
All numbers.
What numbers?
The numbers that will
Is the domain of a function, we talked about this yesterday, is the domain of a function always all numbers?
no.
All possible, what's about, we said, we used a different word, all, the set of all input values. All the things you are allowed to plug in. All the things you're allowed to plug into the function. What are you trying to avoid? There were two things you're trying to avoid. The square root of negative numbers and dividing by 0. Those are the two things you want to avoid. We talked about that yesterday. You want to avoid square rooting negative numbers, and you want to avoid dividing by 0. Now, we didn't really talk about it too much, but what is the range then? What do you think the range is? Let's see. Judging Jackie, what do you think the range is? I gave you the domain. Range is very similar. Yeah. Read it out. What's the range going to be? The range of a f of x is what? the set all, yeah, output values. And we're going to come back to this in a second, but which one is generally harder to find? Range. Range. This is harder to find. I have to teach you something new for you to be able to find the range consistently. And still, even when I teach you that method, it's not going to work in all cases. Sometimes it's very hard to find the range of a function. Domain, you have many tactics. Anything else people want to add into domain and range? Yes?
I got the way that you write the range.
Ah, the way you write, we'll say domain, yeah. Yeah. X such that X something, right?
No.
That one?
Another one.
Ah.
The parenthesis.
You mean like, so for example, let's say, I think I understand what you're saying. Let's say we want to say all real numbers less than 4. What's another way to write that? X such that X is less than 4. And another way to write that is, you're talking about this.
Yeah, that one.
This we're going to call sentence form. We'll call this set notation. And the last one, does anybody know what the last one's called? Begins with an I. Interval notation. Yep. They all three of those things say the exact same thing. So whatever one you're most comfortable with, that's fine. The one I default to, I do this most often. That's just what I got in the practice of doing in college. So you might default to that, but this is fine too. Is this a coordinate? No. Can you ever, what does this mean? I have a question for you, just so you can understand this. There's only one thing you need to remember. What does, that's something different here. What does that mean? What's the only difference?
Less than or
Equal to 4. This means x less than or equal to 4. Can you ever have equal to infinity? No. Infinity is not a number. It's not something you get to. It's something that you approach. Something that you approach. Always growing. So, would it be safe to say you guys know a pretty good amount about these first two? Yeah. We're going to still talk about them. So let's talk about these things. So we have, on Unit 1, 4 ways to represent a function. The question is, what is a function? Simple question, right? Or it might be simple. You've all dealt with functions, right? What's a function? What is it? What can you tell me a function is? You've all spent hours. What? A graph is a representation of a function. Yeah, absolutely. It can be a line, doesn't have to be. Wait, we have a winner over here. What did you say? A relationship, I like this. Between, I'm going to clean it what you said a little bit up. Between two, you can actually have or more. I'm not going to put that in because we're not really going to be doing that too often, but two sets. We already said the two sets. What are the two sets? The domain and the range. The input and the output. Yeah. It's a relationship.
So that would be X is input and
Y is the output. Exactly. That's the most general case that we see, the most common. All the X values are the input values, all the Y values are the output values. That's generally speaking what we see most often. We good so far? Now, I'm going to give you another truism here. All functions are relations, but not all. Anybody want to finish this? Yes. Yeah. Has anybody seen something like that before? Now, you have something to test to see if a relationship is a function, and I'll give you a hint. Ready? This is a relation. Why is that a relation? Well, all those points are on that squiggly thing, right? They're on the path. That's a relation. Is this relation a function? Is it a function? No. Why is this not a function? What kind of line? A straight line? What is that? Oh, this is vertical line. Yeah, there you go. So we like vertical lines, right? And what do you know? So I can draw these vertical lines. So what? I can draw these vertical lines. What's the problem? Passes through more than one. There's 2 points of intersection. If any line, any vertical line can be drawn that passes through more than 1 point, it is not a function. This is called, what test is this called? Vertical line test. And the big kid way of writing this is this. Let's see if I put it here. Oh, I didn't write it in. There's lots of different ways you can say it. I'll clip this into your notes just so you have it. Here's the big kid definition of a function. They like to use the, sometimes you hear rule. But then for vertical line test, how would you want to state the vertical line test? A relation, I'll get you started. A relation is a function if what? So if you cannot draw any vertical lines that pass through more than 1 point on the graph of the function. So this is really good at actually proving something's not a function. Is it pretty good at proving something is a function? Kinda, because is it ever possible to draw all vertical lines? No. This is good for guessing, right? Or on very specific circumstances, or something that this is definitely not a function because I can draw a vertical line through it. It's better at proving something's not a function, right? It's better at proving something is not a function. So the big thing for 1.1, the big thing for 1.1 are these right here. 4 ways to represent a function right here. Which one of these 4 methods are you most familiar with? What do you think? Graphically? I would say graphically and algebraically. You generally write an equation, and then you, for a graph, you show a picture. Well, use a different word than graphically, but show a picture. So I'd imagine you're familiar with algebraically representing a function and graphically. Side note, if you have no idea the quick method of drawing a function, graphing a function, what can you always do? Yeah, plot points. I could give you the craziest function, right? And could you get a decent idea of what it looks like by just plugging in points? It's connecting the dots, right? You know, the little kid, you know, doo-doo. Sometimes you might have to use your calculator a little bit. But then what can your calculator do for you? You can graph a lot of stuff, right? The functions need to be in very specific formatting, though, right? Okay, so the ones I want to talk about briefly, or in a little more detail, verbally and numerically. Let's do the one that's a little bit easier to say. What is numerically? Yes, with numbers, yeah, but to numerically describe a function is to describe it with a... What'd you say, Macy? If I want to numerically describe a function, what am I using? You just said it a little while ago. A minute ago. I want to describe a function not with sentences, but with a something of values. A what? I can't hear you. A table of values. You can make a table of values. You have your x coordinates and your inputs and your outputs. Now, what about verbally? What's a verbal description of a function? Yeah, it's in sentence form. Yeah, it's a description. Now, here's the thing. It's not saying, you know, if I said, here's an algebraic x squared plus 9. Here's an algebraic representation of f of x. A verbal representation kind of is saying you could write out x squared plus 9. You square every input value and you add 9 to it. That's fine. It would be nice if you're a little bit more descriptive. You could say something about this is a parabola. it faces up, and it has a y-intercept of 9 and a vertex of
Um,
0, 9. There's no b value. That would be a proper verbal explanation. You could write it down or say it out loud. Do you understand what I'm saying? A verbal explanation is not just translating what it says algebraically, but saying it out loud. You'll have practice with this. It'll default usually back to algebraically and graphically, but you need to be able to work with all four, because sometimes you'll be given a function verbally, sometimes you'll be giving it numerically. You've worked with tables of values before, I'd imagine, right? Kinda, maybe. What's one thing you've done with tables of values? Does anybody remember? You did this frequently with tables of values, I think. Yeah, and then what's your goal? You're looking at a table of values, you're finding differences. What's your goal when doing that? Yeah, finding an equation from a table of values, right? Can that be pretty straightforward? Sure. Can that be very complicated? Yeah. If I gave you a bunch of points, have you seen things that look like this? Does this kind of sketch remind you of anything? What does that mean? Oh, there's a phrase I want you to get. What? Two things. Line of best fit, and what's that called? A something plot? We will talk about this too. Not now, but line of best fit and scatter plot. Now here's the thing. We're going to talk about these later, but they're all very much related. The table of values is a numeric representation, right? But then we might draw a line of best fit and come up with an algebraic representation. And then we might be able to tell a little story and project, if that was real life data, what's going on. Any questions so far about what we've covered here? Any questions so far? We're pretty good?
Wait,
yeah.
I want to know what is the meaning of scatter plot.
Scatter plot, we're going to talk about it later, but the idea is you might do an experiment and gather data, and you will graph the data, and it'll look like this.
Yeah, and then you...
That is a scatter plot.
Oh,
and then from the scatter plot, you might come up with a,
line of best fit.
or in this case, a parabola of best fit. When you get past lines, or even when you use lines, has anybody used this magical device to find lines of best fit? Have you done that? How many people have done that before? Used your calculator to find a line of best fit? Kind of, some of you? How many people think they could do it right now if I gave you a table of values? A couple of you maybe. Unless you practice it, you tend to forget. I forget too. Okay. These are called the what? The x-intercepts, also called the zeros. You've done these extensively, but we don't have a function. We don't have an algebraic equation to deal with, so you have to look at it. You have to estimate it, right? So for D, Wilbur, what did you estimate for D? For D, what? Negative what?
1.
I don't think negative 1 is right here. Does it cross there? I don't think so. Anybody have an estimate they want to give me? Covert. Negative 3? We're looking for this value and this value right there.
Negative 2.5.
I think negative 2.5 is a little better.
0.3.
Like 0.3? About that? Maybe 0.25? Does that make sense? You're looking for where does it cross the x-axis, right? What about E? Now this is where it gets fun. Caitlin, what do you think the domain of this function is? Okay. Anybody have the domain they want to... Macy, what do you think the domain is?
X is greater than or equal to negative 3 and but less than
To what?
but less than
To 3, yeah. Because the farthest this function stops at 3, and it goes back to negative 3. I think that's great. You can write it like that, interval notation. That's okay. You could also write the same thing as negative 3, comma 3. Is that a coordinate? No, that is interval notation for the domain. Now, did anybody get the range of this function? Raise your hand. Let's use hands. Range. Bissell, what do you think? Oh, actually, let's go. Denise, what did you get?
I have negative 2
Yep, that is, yeah.
and then 3.
Up to 3. Yeah, exactly. Good. Now, how did you get that negative 2? Why did you choose negative 2?
Because it's
Mm-hmm. It is the lowest value the function takes. And what's the highest value the function takes? 3. You can write that. That is the range. Very good. That's great. Yes.
How do you know if it's is it less than or equal to or less?
You can't really on these because you assume it's going through the value, okay? You have to assume a certain degree of accuracy. Do you understand what I mean, everybody? You don't know exactly what this function does. This function, if you zoomed in, it could look like this. It could be freaking out, right? Do you know if it is or not? No, you don't. You're making some assumptions. One of the assumptions you can make is that it's going to go through -2 and it goes through those values, okay? You can make that assumption. Okay, so we did E. Let's talk about F here. Oh, that was still E, sorry. F. Did anybody get to F? Intervals of increase and decrease. This is a little tricky. We didn't talk about this, but maybe you can think about it because you've done it before. Yeah. Where is it increasing?
From -1 to 3.
Yeah. It's increasing from -1 to 3. And where is it decreasing? Someone else. Where is it decreasing? Who hasn't? Anybody who has -3 to what? To -1. Exactly. Now, that includes everything except the endpoints and -1. What's happening at -1? Is it increasing or decreasing? At x equals -1, what's the function doing? Is it increasing? Is it decreasing? No, it's not increasing or...
It should be like greater than or equal.
That's correct. It should be greater than. No equal to. The function is not increasing or decreasing at these highest or lowest values. Also, the endpoints. Is the function increasing or decreasing at 3? It's not. It's an endpoint. If you take AP Calculus, you will study this in detail, the idea of increasing and decreasing. But for now, you guys get to estimate. Sound good? Let's say I gave you the function. Let's say I gave you some crazy function like the formula for this. Let's say I gave you the formula for a function that looks like this. If you wanted to know where it's increasing and decreasing, you would have to know that point, that point, that point, that point, and that point. What's the only way you have of finding those points right now? Calculator. That's the only way you really have right now. How many people have found coordinates like that on their calculator? Have you ever done that before? Let's just give a quick review of this just so you can have something to play with later. Put your calculators down for now, everybody. Just watch. If you go into y equals, and let's give it something, I don't know, pretty fun. Let's go with x to the 4th minus x squared minus 6. Let's see if we can graph this and see what it looks like. Goes up, goes down. Let's zoom. Remember zoom fit, everybody? Do you remember zoom fit? Ooh, fraction. Let's go to zoom trig. Zoom fit can help a little bit. This function goes down. It goes up. Now, if we wanted to find the minimum value of this function, that might be a little hard. Might be a challenge. Inside your calculator, second calc, do you see this maximum and minimum function? Does that kind of ring any bells? So, for example, let's make this a little simpler. If we did x minus 2 times, I don't know, x plus 3, and we zoom standard this. Let's say I wanted to find that exact minimum. Second calc minimum. What's it going to ask you for? Left bound. And then it asks you for right bound. And then you want to guess. So you go to the, it's right about there. You enter. What's the minimum value of that function? Negative 6.25. Where is the minimum value? At the x value, 0.5. When you get an answer like this on your calculator, when you get an answer of negative 0.5000006, what's the actual value? Negative a half. The calculator is estimating. So when it goes that far, it's actually going to, you're about 99% sure what does the calculator mean? Negative 0.5. You can be pretty sure about it. But the calculator is estimating. So the calculator can help you here. We feel pretty good about that one question? Right here. You're looking at it from left to right. Where else is it increasing? Can someone tell me where else it's increasing?
The last part.
From C onward, right?
Yep.
From C onward. So it's also increasing right here. I wouldn't pack up, because if you pack up early, then you have to unpack your whole bag and it gets really annoying. Where's it decreasing?
A, go on A, B.
A to C.
Oh, yeah, A.
Do the B and the D values matter at all here? Not really. Except to make sure it's increasing and decreasing. So this is decreasing right here. So you could say it's increasing from negative infinity to A. It's decreasing from A to C. And it's increasing from D to infinity. Is it increasing or decreasing at A? Neither. Okay, your homework tonight. Your homework is in the packet. It's going to be numbers 2, 5 through 8, as well as the ones on this next page. You're going to do 12 through 17. It's in the packet we worked on today. So please do that. Have a good day, everybody.
Mr. Seamon.